Good morning, everyone. Today's lesson is 5.5. Technically, in your book, it calls it performing function operations, but same thing. Okay, it's actually very simple. It's kind of things that we've already done in other lessons, just not with this notation. There's just one added component. So let's just read through these notes, make sure we understand the notation. If you have two functions, so here we have f of x, which is a quadratic function, and g of x, which is a linear function, where the domain of both of these functions is all real numbers, right? All real numbers. Then what we can do is we can add, subtract, multiply, or divide these functions, okay? Now the notation is really the only new piece of information here. If I want to take these two functions and I want to add them, I could just say that f of x plus g of x is equal to f plus g of x, okay? We'll also see it written differently down here as well, okay? That's all that means. And literally all you're doing in this case is you're just combining like terms like we've done in other cases, combining like terms, okay? And this part less important, but you could highlight if you want. The answer you get is what we call the sum function, okay? So f plus g of x is equal to f plus g of x. Then if I wanted to subtract the two functions, f of x minus g of x, again, a notation or a new way to write that is f minus g of x. And again, just like we've seen before, we will, again, combine like terms, but the first thing we'll have to do is distribute the negative and then combine like terms. So that's when you're subtracting. When you're multiplying two functions, so f of x times g of x, we can write that as f times g of x. And in this case, what we're doing is we're going to distribute or FOIL depending on the functions, okay, and then combine like terms. Okay, so far all things that we've seen before. Division, if you wanted to do f of x divided by g of x, another way of writing that is f divided by g of x. And in this case, you're going to divide by factoring and canceling like denominators, or like factors, sorry. Or, depending on the problem, you could do long division or synthetic division. But a lot of times you're just going to factor and see if anything cancels out, okay? All right, so again, down here you see it broken down a little bit in a more concise way, the different ways that you can write the notation and what it means. This also is a new part, finding the domain of the functions. Okay, this is using a notation that we've seen before. To find the domain of the sum function, the difference function, the product function, the quotient function, you're basically looking for the intersection of the two domains. So the intersection of domain of f, the intersection of domain of g, which a very simple way to think about that is like, what do they have in common? Where do they overlap? That's what that means, okay? So this is just saying, where do the domains overlap? And then the only added component when we're doing the quotient function is that you just can't have a denominator of 0, so that's what that piece means. G of x, since that's the function in the denominator, cannot equal 0, since we can't divide by 0. Okay, so it also says up here, if you want to highlight this part, because I feel like it writes it nicely or notates it nicely, is that any number that is in the domain of both functions is in the domain of the combined function, okay? So let's just go straight to an example and see how we would complete it. So f of x is equal to 3 times the square root of x, and g of x is equal to negative 10 times the square root of x. Find f plus g of x and state the domain, then evaluate f plus g of 4. Okay, so one thing at a time. Let's find f plus g of x. So here I'm just adding the two functions. So f plus g of x, remember, you don't have to write this, but you can, is just f of x plus g of x. So that's going to be just 3 times the square root of x plus negative 10 times the square root of x. Okay, so basically we're just combining like terms here like we did in other lessons in this chapter. So that's just going to be negative 7 times the square root of x. Okay, that's the sum function. Okay, then it says state the domain. So remember, the domain of the sum function is going to be what they have in common, what the domain of f of x has in common with the domain of g of x. So in this case, the domain of f of x, because it's a square root function, remember we just can't have a negative under the radical. So that means the domain of f of x, I'm going to write it down here, has a domain of, let's say, bracket 0, comma, infinity, right? Anything greater than or equal to 0 is in the domain of this function, okay? Let's say it was 3 times the square root of x minus 2. In that case, you do x minus 2 has to be greater than or equal to 0, in which case the domain would be anything greater than or equal to 2. Okay, just to show you what a different type of problem might look like. Okay. G of x has basically the same domain. Okay, because same thing, it's a square root function, so I'm just going to copy and paste this. They both have a domain of bracket 0, comma, infinity. So where do they overlap? They overlap everywhere. So what that means is, so the domain of f plus g of x is, again, just bracket 0, comma, infinity. Okay, last step. Evaluate f plus g of 4. Since we already know what f plus g of x is, we can just use that to evaluate f plus g of 4. I can take this expression and just evaluate it at 4, or plug in 4 for x. So that means I have negative 7 times the square root of, instead of x, I would have 4. The square root of 4 is 2, so negative 7 times 2 is negative 14. And that's the end of that one. Okay, more examples. B, f of x, which is a cubic function, g of x, which is also a cubic function, and we want to find their difference. So one thing at a time. If you want, you can write that as f of x minus g of x, which means I'm doing 3x cubed minus 2x squared plus 5 minus, and then in parentheses, because I have to distribute, x cubed minus 3x squared plus 4x minus 2. And now I'm going to distribute, and when I distribute, I'm just going to write it underneath, so that way you can put all the like terms together. So negative x cubed plus 3x squared minus 4x over here, and then plus 2. So what is f of x minus g of x? It is 2x cubed plus x squared minus 4x, so it's in standard form, and then plus 7. Okay, that is the difference function. Okay, now I want to find the domain of the difference function. This one is kind of similar to the previous one because since they're both polynomials, the domain is just all real numbers. So the domain of f of x is all real numbers. The domain of g of x is all real numbers. So where do they overlap? They overlap everywhere. So the domain of f minus g of x is all real numbers. Okay, last thing, we want to evaluate the difference function for negative 2. So again, I'm just going to plug in negative 2 for x here. So that's going to become 2 times negative 2 cubed plus negative 2 squared minus 4 times negative 2 plus 7. Negative 2 cubed is 8, negative 8. Negative 2 squared is positive 4. So this is going to be negative 16 plus 4 plus 8 plus 7 So that's going to give us -8. That's going to give us -4. So that's going to give us 3. Okay, so f of g of -2 is 3. Okay, now let's go on to the next one. Here we want to find the product of the two functions. So f times g of x means we're doing x squared times the square root of x. Okay, now, we learned in the previous lessons that the square root of x can be rewritten as x to the 1/2 power, okay? Which means that because I have same base and we're multiplying, I can just add the exponents. So in other words, x to the power of 2 plus 1/2, which is 2 1/2, or I could just write that as x to the 5/2 power. Okay, and that's how I'm actually going to choose to leave my answer. Even though technically I could write that as the square root of x to the 5th as well. Okay, both correct. What I'm going to do now, like I've done for the other problems, is find the domain. Now this one is going to be different because I have two different types of functions. So the domain of f of x is all real numbers because it's a polynomial, it's a quadratic. But the domain of g of x is everything greater than or equal to 0. So in this case, the domain of f times g of x is where they overlap. So where does all real numbers overlap with anything greater than or equal to 0? Where do the blue and the red overlap? Well, wherever the red is. So that's what the domain is. It's everything greater than or equal to 0. You could think of it as taking, sometimes you could think of it as taking the more restrictive domain. Okay. Now I want to evaluate f times g of 9. So actually maybe it's better to leave this as the square root of x to the 5th for this problem. Because here, if I do the square root of 9 to the 5th, I get 3 to the 5th, which is 243. Okay, very good. D, we did addition, subtraction, multiplication, so now division. Here I want to take this function f of x, which is a linear function, and this function g of x, which is, we would call this a radical function, because remember, this x to the 3/4 power could be rewritten as the 4th root of x cubed. Okay, so I want to divide these two functions. Not too bad. That's going to be 6x over x to the 3/4 power. Just like we saw in the previous problem, because I'm dividing, same base, I'm going to subtract the exponents, which means I have 6 times x to the power of 1 minus 3/4, which is just 6x to the 1/4 power. Okay? Again, that's 6 times the 4th root of x. Now, domain. Here it's going to be a little bit similar to the previous one. The domain of f of x is just all real numbers because it's linear. But the domain of g of x is going to be everything greater than or equal to 0 because of the radical, the even root radical. So where do they overlap? When we have a domain of bracket 0, infinity. So f divided by g of x has a domain of everything greater than or equal to 0. Okay, last thing. Oh, sorry, I forgot one other thing. Because this is the quotient function, it's not just the overlap, we also have to look at the answer that we got, not just at the end, but from the very beginning, and see what would cause division by 0. So because you have x in the denominator, we have to adjust our domain because x can't be 0. If x is 0 here, we would have 6 times 0 over 0, and that's undefined. So not only do I have to check the overlap, but I also have to check what causes division by 0. And since 0 itself causes division by 0, that needs to be excluded. So instead of a bracket, we'll have a parentheses there. So that's the adjustment. Okay, last thing. Here I want to find the value of the quotient function when I evaluate at 16. So that's just going to be 6 times the 4th root of 16 from when I converted it to radical form. And the 4th root of 16 is 2, so 6 times 2 is just 12. Okay, a little bit harder problems. For this particular example, I want to find the sum, difference, product, and quotient, and then state the domain for each. Okay, so let's just do one at a time. For the sum, f plus g of x. I'm going to do the square root of x minus 1 plus the square root of 4 minus x. Now remember, to combine like terms with radical functions, I need the root to be the same, and I need the radicand, or what's under the radical, to be the same. So the root is the same, but what's under the radical is not, so I can't do anything. This is my final answer here. Okay, so that's my final answer. Okay, now difference. It's going to be similar. Square root of x minus 1 minus the square root of 4 minus x. Same thing. Can't combine like terms because the parts under the radical are not the same, so that's that. Product. Okay, in this case, I am multiplying. And when we're multiplying, as long as the root is the same, I can combine them under the same radical. So that means I have the square root of x minus 1 times, I'm going to reorder this part, the square root of 4 minus x to be negative x plus 4, which means if I do FOIL, it'd be negative x squared, that's going to be positive x, positive 4, so positive 5x, and minus 4. And then, that's as good as it gets. I can't do anything else. I can't simplify that because I have to combine like terms under the radical before anything can be pulled out, so that's my final answer. Sorry, I forgot to circle this one. Okay. Last one, quotient. Okay. So this is the square root of x minus 1 over the square root of 4 minus x. Now here, I can't really simplify anything in the sense that I can't cancel anything out, but what I can do is rationalize the denominator because I'm not supposed to leave a radical in the denominator. Now the good news is I've kind of already done that, or I've kind of done part of that in the previous problem, so let's just add it to this. So to get rid of the radical in the denominator, I have to multiply top and bottom by the square root of 4 minus x, which I already know what that'll give me in the numerator. It'll give me the square root of negative x squared plus 5x minus 4. And then the denominator, it'll just be 4 minus x. And that's my final answer there. Okay. So we've done the sum, the difference, the product, and the quotient. Now the nice thing is that the domain of the sum, difference, product are all going to be the same. The quotient's the only different one. Okay, so let's first start by finding the domain of just f of x and g of x. The domain of f of x has to be anything greater than or equal to x minus 1 because what's under the radical has to be greater than or equal to 0. Can't be negative. So x is greater than or equal to 1 in this case, which in set notation is this. Okay, anything greater than or equal to 1. This is interval notation. In set notation, it would be x such that x is greater than or equal to 1. I'll put it in both forms. Okay, g of x. Again, what's under the radical can't be negative, so it has to be greater than or equal to 0. So that means 4 has to be greater than or equal to x, or x has to be less than or equal to 4. So in interval notation, anything less than or equal to 4. Okay? All right, now, to figure out where they overlap, you could draw a number line and do it like that, or you could just think about it. But I think a number line would provide a good visual for us. Okay, so I'm going to have 0, 1, 2, 3, 4, 5. The domain of f of x is everything greater than or equal to 1. So that's f of x. And the domain of g of x is everything less than or equal to 4. So where is it that they overlap? They overlap here. So that's going to be the domain of the sum, difference, and product functions. Okay? So the domain of these three is everything between 1 and 4, including 1 and 4. Okay, now the domain for the quotient function is basically the same thing, except I just have to make sure I include or exclude the values that cause division by 0, which in this case is going to be 4. So that means that the domain of the quotient function is the same, but I need to exclude 4, so a parentheses instead of a bracket there. Okay, very good. Last example. Here you have two functions. You want to find just the quotient function and then state its domain. Okay, interesting, because you have square root function and absolute value function. So that's kind of interesting, but not too bad. Okay, so that would just be the square root of x over the absolute value of x minus 3. There's no rules against having absolute value in the denominator, so that's fine. And there's really no way to simplify this, so that's actually my answer. Okay, now, to find the domain of this function, I need to find the domain of f of x, g of x, and then exclude what causes division by 0. So the domain of f of x is everything greater than or equal to 0. The domain of g of x is all real numbers. And what causes division by 0 is just when x equals 3. Okay, so if I was to put this on a number line just to give us a visual. 0, 1, 2, 3, negative 1, negative 2. Okay, so the domain of f of x is everything greater than or equal to 0. The domain of g of x is all real numbers, but x can't equal 3. Okay, so this is how we would write that, even though it's going to look a little weird. The domain would be, this is where the overlap is, 0 to 3, not including 3, in union with 3 to infinity. Okay, that would be the domain of the quotient function. Okay? And that's the end of the lesson.